Good. So welcome to this webinar on the new AirGradient ONE. So what I'm gonna do is I think we need around 20 minutes. I have a few slides, and then we can go into some Q&As. I want to start with some general news, and I think probably the most interesting thing for a lot of you is really an update on the shipment. So I think we are pretty much on track. We shipped a lot of the kits and the units over the last weeks, and we're gonna ship a lot more in the next 2 weeks because we got a new batch from the factory with these assembled PCBs. They all look very good. We test a lot of them, and I believe we are on track to ship like the orders until mid-December as communicated last time. I also wrote in one of the last shipment updates that I sent by email. So in case somebody of you needs it really, really urgent, then just drop me a line and we can prioritize that. So we have all the components, all the stock is there. It just needs time to ship them because we actually test every kit before we ship it. So we actually assemble it, we test every component, and then we kind of disassemble it and ship it. This takes some time, but it also guarantees that at least at the point of shipment, everything was working. We sometimes don't know if it was handled very roughly in the shipment provider, but I would say 99% of the kits arrive in very good shape. Now, a little bit about general update on AirGradient. You might be a little bit curious. So we really saw that we need to work a little bit more on the, let's say, on the software side in general, especially after with this version 9 of the indoor kit. I think we have a very good state of the hardware. So we actually hired a couple of developers. Two actually work on the front end and the map. The map is in a very initial state, if you have seen that. And a major focus will also be on really improving the onboarding, the user friendliness. We also want to put, this was actually a feature that was requested a couple of times, put more explanations like into the dashboard, like what does a PM of, let's say, 50 mean? Is that unhealthy or not? What should be good CO2 levels, and all these kind of things. We also want to put in a bit more about how you can actually calibrate the sensors, how you can ensure that they stay accurate. We have a very strong science team that's mentioned under here, and so I think we are very well placed in bringing more of this kind of calibration knowledge into the application itself. Then on the firmware side, we just started with a new firmware developer, and we really want to catch up on the RDE library. We want to offer platform I/O support in parallel, and we also need to add a few missing features into the firmware. Like, for example, the CO2 baseline calibration was a separate code in the past. And also, like with the new LED bar that we have in that board, we want to offer more customization potential. And then I think one big thing also is like we are working on improving the customer support process. At the moment, some emails just fall through the gaps, I would say, and nothing intentional. So in case you don't get an answer, just resend it. But we are working on improving that. Just a quick detour to the outdoor monitor, because it has some implication on the indoor one. So we grew our co-location space. That means we test the outdoor one in many places around the world now against reference instruments. Most of them are like universities, and because we use the same or nearly the same PM module in the outdoor monitor, we can actually get a lot of knowledge through that we can use for the indoor one. So here is just some pages from pictures from all around the world where we have the open air co-located. This is in Nepal, for example, India, Ghana, Canada. We have stations in the US, in Europe, across Asia. So a lot of things going on there. And we also started really looking into how can we actually improve the performance of these low-cost sensors, and having really good progress there. All the work we do on the scientific side is also open source, open data. We have a research section on our website you can visit and have a look if you're interested to learn a little bit more about that. Just last week, we actually got 3 awards at the Microsensor Challenge 2023, which is a big event, I think every 2 years, where a lot of sensor manufacturers actually send their devices to test. This time it's actually a French institution from Paris. This time it was run in Thailand and in France in parallel for the outdoor monitor. And what we were really happy about is that, especially the first one, that the AirGradient ONE got being awarded the best or the most accurate multi-pollutant sensors under 500 euros. And I think it's really a testament that open hardware can also produce the best quality. And so that was really a very strong motivator for us to continue on this path. Yeah, by the way, I'm gonna share this presentation later on, so you can have a closer look on the results here. So let's dive a little bit into the new version of the AirGradient ONE. So for us, as a company, we had, before the AirGradient ONE was actually a closed source commercial product until version 8. And then we had these DIY Pro boards running in parallel using exactly the same sensor modules. And last year we decided, okay, we want to really merge this. And it took a while, but now the AirGradient ONE is basically just one more version. So there's no more open source or closed or whatever. There's one version, which is completely open hardware. And it's just kind of simplifies our product range, and I think makes it also a lot more powerful, basically, because we can focus just on one layout, design, and make it a lot better. So the main technical improvements compared to the old, let's say, DIY version, which was based on an D1 Mini before. So we have a much more powerful and newer microcontroller with the ESP32C3. What's also a great thing is now you can actually flash it through the USB port. Before, you might remember, in case you had the old version, you had to actually open the enclosure, plug it into the D1 Mini, because the kind of data lines weren't exposed to the pins of the D1. What we added also is an external hardware watchdog. You can see the small chip here, which actually reboots the device if it doesn't get a heartbeat, which you can send through the firmware. And that really gives you very, very high uptimes, because you can just kind of reboot the device in case it crashes. And we also added an RGB LED bar based on the WS2812 addressable LEDs, which are very popular and a lot of you might know, which basically lets you choose or pick a color for each of the LEDs, and gives a lot of possibilities on doing something interesting with the LED bar. Also, that thing you see on the bottom left, we have a better thermal isolation for the temperature sensor in that board. Now, going a little bit into more details here, that's a different break, or it's a more rendered graphic, but I want to point out a few more things here. So We have an I/O breakout for extensions. That's basically this JST plug here. And on the right here, you can see what's actually what you can connect to here. So we have the I2C ports, 3 volt, 5 volts, ground, and then 3 more IOs that were basically left from the C3 Mini, which you can use for any purpose. There are also a few holes, like, for example, on top of the OLED display or here, where you could actually potentially mount additional boards. We also broke out a few more I2C ports, which you can see here, like here, for example, on the side. On the top is one more. And we have also broken out for the Bosch environmental sensors. I think it's 5 or 6 pins that you can put in these VOC or pressure sensors from Bosch that I think some of you are using. And then we also have broken out basically an external connector which you could solder onto the PCB in case you want to have another port next to the USB port. And then, yeah, maybe feed in some, I don't know, additional information lines or whatever you want to do. And then on the opposite side, obviously, is the display and the 11 RGB LEDs. Then from the sensors, it's exactly the same as before. I think they all have been proven to be very reliable, and we are very happy with them. I don't want to go into too much detail today into the sensors. One more thing, so it's open hardware, so we have everything on the website. So we have the source code that we currently really work on improving a lot. The schematics are there, the KiCad files, which includes the BOM and the PCB design. And then we have also the enclosure files as step file. And you can find this under this address here. And then you could, yeah, like use that as a base and modify it or build it yourself, whatever you like to do. One quick thing, we sent this board through certifications to a test lab. So we are ROSE REACH certified. REACH is like 280 chemicals in the EU. We did EMC testing, electromagnetic fields, so everything has passed. And the device is also reset air accredited. So that's actually similar to the Air Per Reef Challenge. It's an external provider that tests the accuracy of the monitor. So one more thing there, maybe if you might have noticed on our website, we don't mention the certifications at the kit and only for the fully assembled. And the reason is that we don't really know what people do with the kit. So for example, if you solder in your extensions and you use a leaded solder, obviously it's no longer ROSE compatible because of the iron or the lead. So we we don't want to give the false impression that like you can assemble the kit whatever you like it and then it would still be certified. But if you just assemble it the way it is, it's exactly the same unit as the fully assembled one. And the certifications can be accessed here on the website. Good. Let's talk a little bit about firmware. So one thing is important. So we also had a bug a little bit in some of the firmware versions. So what's really important is once you get the kit, please, first thing to do is update the firmware. The easiest way is through the web flasher. You can click here, and I just answered this morning a question on the forum. Like in case it gives you an error message or some kind of boot thing, you need to press the boot button when you plug in the USB port, and then it goes into a special boot mode to flash. In most cases, this is not required, but sometimes it is. So I will actually add a bit of better instructions on the website. We have also a very good running ESP Home version already. And you can find this under our integrations page. And then you can go directly to, I think, the GitHub from the ESP Home integration that we recommend. So what's currently not yet supported is the configuration of the RGB bar. So at the moment, it just shows you, depending on CO2 levels, colors on the bar, and also the CO2 baseline calibration. So this will be one of the next things that we're gonna add to the firmware, so to give a little bit more flexibility there. So I want to go just very quickly through the build instructions. So the build is actually super simple now, I would say, because the way we ship it, we already mount the PM sensor on the PCB and the PCB into one half of the enclosure to protect it from, especially the OLED display, if it's a little bit sensitive, if it's just kind of not very well put in place. So we actually screw that into one half of the enclosure already. So the only thing you have to do is actually plug in like 3 sensor components and then close it. And I want to just go very quickly through the build instructions. So there's a QR code as well in the box, and you can scan, and then you get basically to the build instructions. What's important for people that also have older versions or the outer one, there's an overview page on each of the instructions page that actually then lets you identify if you have an older board to go to the correct instructions. So I already explained the PCB. So this is a picture of the 11 LEDs. So we actually made it as a separate small PCB that is soldered onto it. And one of the reasons is because we have, sometimes some of these LEDs might fail in the future. So this is actually giving an easier way to replace that LED bars in case there's a faulty one, for example. This is the assembly video. Actually, it should not be for previous version. It's actually for this one here. So you can watch the video. It's here explaining the components and the schematics. And then I want to go in here. So here you actually see the 3 components in the middle are actually the ones that you need to mount. The PM sensor with the cable is already connected when you receive it. So CSPC3, yeah. So you can start with the temperature module, which is the SHT40. And one of the mistakes that sometimes happen is that people actually plug this in the opposite way. So that small AirGradient logo icon always needs to face outwards. And you can also see it here, like, for example, you see like SDA, and you see SDA labeled here. You see VCC, which is actually the voltage 3 volts. So you can also orient yourself with that small labels. But if you actually accidentally put it the wrong way, so the board will not get destroyed or anything, but it will not turn on. So nothing will appear on the display. Okay, so this would be the first thing to check. Then just plug in the CO2 sensor here. Also, this one, there's only one possibility because one side has 5 pins, one has 4 pins. The PM sensor has already been installed. If not, there are like basically 4 screws that you can screw it on the PCB, and then that JST connector. Maybe one thing also good to know is we use crossover cable for the PM sensor. So in case you use a cable from another source and somehow it doesn't work, just check that it's actually crossover. Okay. Then we have the screws, and then, yeah, that TVOC sensor, same thing. It's just on the opposite side of the board. on the top. Same, like icon should face outwards, and then you can actually put it together. The PCB is already screwed in. Yeah, and then like you might have noticed, and that's a funny picture here, that we provide a small screwdriver, and some of the screws might be a little bit difficult to get in. And then most of the time people have a larger T6 screwdriver, but if not, one trick is actually put a little bit of soap on the screws, and it will just much easier get in. Power supply is not included. You need just a standard USB-A 5-volt 2 amp power supply. Pretty much any phone charger works, and the unit doesn't need a tremendous amount of power. So even like old chargers typically work very well. I already talked about the flashing. Good. Just a few more things. Possible mistakes or problems that sometimes pop up. I think I mentioned the first two already, so make sure that small modules are mounted the correct way. The flashing will not work, then press that boot button. I mentioned that. I will also make it clearer on the website. In case the PM sensor or any other sensor shows -1, this could indicate that it's not connected properly. So like, for example, the PM sensor, maybe the cable is not fully plugged in, and so on. So this could be the first thing you can do. I mentioned this, put a little bit of soap on the screws in case the screws are too hard to get in. And Wi-Fi hotspot does not show up. So we had a few units that we flashed with a firmware version that had problems with the Wi-Fi. So just make sure you update it once you receive the unit. Good. So that's so far from the presentation. I will just see if I can. So yeah, so if you have any questions, you can either like just ask now or put into the chat. Yeah, so far I don't. Okay, so does the CO2 sensor need to be outside during calibration? Yes. So the calibration for CO2 basically, yeah, let me explain that a little bit. So by default, the CO2 sensors do automatic baseline calibration. That means, like, I think every 7 to 10 days, they look at what is actually the lowest value they measured, and then they reset themselves to have that value defined as around 400 ppm, which is the outside CO2 levels. Now, there are a couple of problems. First, when you receive the unit, due to transportation and vibrations, in some cases, the CO2 sensor is just totally off, and sometimes people don't want to wait for a week to calibrate it. So what you can do is basically, at the moment, we have in the Arduino library a special sketch, an example code that you can flash on the device, then bring it outside with a power bank. Wait maybe 5 minutes so that the air is inside the enclosure, and then run that sketch, and then it would reset it immediately to 400 ppm. What we sometimes see in, let's say, in very badly ventilated places, like also maybe in basements or low energy hours, that it could be that the CO2 level never reaches the baseline within a week. So what we currently look into is like possibilities to switch off the baseline calibration then, but then we might experience a drift in the sensor. So this is something that we investigate at the moment, what kind of solution we can provide there. I hope that answered, Mark, your question. Then, yeah, from Joshua, yeah, I think it's why we have a crossover cable. It's a bit of a very long historical reason. So somehow the first version we had on the commercial product used the crossover one, and then we just had this in our inventory system, and that's like we stick to it. They're actually pretty easy to get, but it's something at some point we might want to switch, but there's no, I mean, the crossover doesn't have any advantage over the other one. So for the MQTT, it's something that we support at the moment through our platform. I think some people actually have versions of our code to send it directly to an MQTT server from the device. Mark, I can probably look up at something, or you could also search in the forum. So it's something that comes up from time to time, and I think we will probably offer something there as well. Yeah, let me see. Okay, Ethernet is also something which people looked at in the forum, and I think one person actually built something with an Ethernet plug, but I think he had to actually change the whole microcontroller. It's not natively supported as far as I know from the ESP. So it could be that we have something coming up, but it's not something we actively develop at the moment. And I think it could be a great project for the community to pick up. PoE, yes, coming up as well. Maybe one more thing about these extensions. I mean, there are a lot of extension possibilities. You know, LoRa, maybe PoE, maybe just reading it also directly through the USB line. We did once a survey and asked people, hey, like, what kind of connectivity do you prefer? And it was still like 90% were going on Wi-Fi. And then the other 10% was really, really distributed. So that makes it difficult to kind of say, okay, we focus on one particular board that we want to support. But hopefully, one thing we're gonna work a lot more in the future, we actually started now with the integrations page, is to highlight these kind of projects. And if you know, if there are people that just design this, that we can then make that available to the whole community and link to it, and then people can actually use that design. Let me see what else we have. Yeah, okay, so for the CO2 calibration, so what you can also do is just open your Windows or bring it close to Windows, and then it should also reach ambient level. Yeah, so I think typically it's not a problem to get these ambient levels at least like once a week, because it's like, let's say if you open the Windows, it's very fast that it gets very close to 400 ppm. Yeah, thanks, Joshua, for answering the ESP home question. And actually, Joshua maintains that library, so he's the best person to answer that. Good. Let me see. Is there any more questions? Yeah, maybe one more thing in general about the support. So we have the AirGradient forum. We have also on our website a support form. So if you have any questions, then just like reach out. If you don't hear back, I mentioned it earlier, like we trying to improve our support system, then just follow up. And often I also hop on on short Zoom calls if somebody really gets stuck, and so far we could actually solve every single problem. Okay, so if for whatever reason, like you just get stuck and it doesn't work, and just reach out, and yeah, I'm super happy then just to jump on a call, and then we can look at your build, and yeah, and typically we can solve things within a few minutes then.